So on today's lesson, we learned how to complete the square, and even before that lesson, we learned we did a little mini lesson on imaginary numbers. And the only thing that we needed to learn was that I is equal to the square root of negative 1. And with that, with knowing that I is equal to the square root of negative 1, you could say that I squared is really negative 1. Why? Because I times I is the I squared. And we just said that I does equal the square root of negative 1, so instead of I could write it as the square root of negative 1 times I, which is the square root of negative 1. And we all know that when you have a radical and you multiply it with itself, the radical cancels out and you're just left over with what's inside, which is negative 1. So that's why I squared equals negative 1. Let's move on. So jumping right into the completing the square, let's work on number 28, which is an example of completing the square, or where we could apply completing the square to solve the quadratic equation. So the first thing to do is, according to our notes, make sure that the a value is equal to 1. And in this case, the a value is not equal to 1, it's 2. So what I want to do is I want to divide everything by 2. That's the first thing I want to do. And step 1 also says to make space for your new c value. So we're going to have k squared plus 8k, leave space for your new c value, equals, and that becomes a negative 6 over there. Now, what is completing the square? Completing the square is actually taking your b value, which in this case is 8, and taking half of it and then squaring it. So if we think about what is half of 8, that's 4, and if you square it, that becomes 16. So we're adding 16 both there, and we have to add it over here also. Because if not, then the equation would be off balance. You'd have a plus 16 that you didn't have before on this side, which you have to add the 16 over here to maintain the balance, the equality of the equation. So anyhow, we now have a perfect square quadratic trinomial, and the only purpose of getting that is to be able to rewrite it as a binomial squared. Okay, equals a number, which in this case is 10. Now, what belongs inside the binomial? Well, if you take the variable that you're dealing with, k, and write it in there, and then look at your b value, and if your b value, all you got to do is take half of the b value and write it right here. So half of your b value would be 4, and just all you got to do is write in that 4 right there, and you're good. So that's the whole purpose of getting a perfect square quadratic trinomial, to be able to rewrite it as a binomial squared. And now we are able to apply a square root here and a square root there to start solving this thing. And you will get k plus 4 equals plus or minus, whenever you apply a square root in an equation, you have to put a plus or minus in front of it, 10, the square root of 10, that is. For my final step, I'm just going to subtract 4 and subtract 4, so I get k equals negative 4 plus or minus the square root of 10. And yes, you're supposed to try and simplify the square root of 10, but you can't really break that down to any perfect square numbers. 2 and 5 doesn't even help you. So we're kind of stuck right there. We can't do anything else. Which we could finally say, yeah, this is our answer right here. Let's now jump to this portion of our homework that I wanted you to try. You don't have to do every single one here, but just want to go over a couple of things here. Like on number 3, you want to complete the square. So what do? You take half of the b value, which happens to be negative 4, and you do half of it, which is negative 2, and then you square it, and that takes you back to a positive 4. Okay? They want you to rewrite this new quadratic trinomial as a binomial squared. Okay, now the book solutions don't even do this, but I think if you just magically added 4, you should put a minus 4 also. So anyway, when we take a look at the quadratic trinomial, which is all of this, the perfect square quadratic trinomial, now we could actually jump to the parentheses squared situation, and you should have a binomial on the inside of the parentheses right here. So what belongs in there? Well, the x comes down, and that belongs in there. And what else belongs with the x? You simply take a look at b, which is negative 4, and you do half of it, and then just put it right there. Okay, so to complete the square, you do half of it and square it. That's how you get this value. But when you're looking for your binomial squared situation, all you got to do is take half of b, which will clearly be -2. Now, the reason why I threw in this -4 at the very end is because the +4 was not there, and we magically added the 4, so we need to subtract the 4 to make it seem like if it wasn't there originally. So there you go. That's what I would say the correct answer is right there. Even though the book, I believe, only has the binomial squared as your answer. But I think we should not forget that you can't just magically add 4. We're going to subtract also. That way we don't really change anything. It just looks different. Let's move on to something else. Maybe like number 7. I don't know. Or number 8, writing in vertex form. I don't know. Let's do number 7. So on this one, we want to complete the square to be able to get a binomial squared situation, to be able to apply a square root, to be able to solve it. Very first thing I want to do is divide everything by -3 to make the a value a +1. Not only that, I mean, just to make the equation a lot easier to deal with. You have an x squared, you have a -6x, you have an equal sign, and you also have a +10, because -30 divided by -3 is +10. Now notice that I left some space right here. Why? Because I'm going to leave space for my new perfect c value. And how do I do that? Well, I'm going to simply take half of b, right, and then square it and write it right there. So if I do half of -6, it's -3, and if I square it, I really do get a +9. So because this is an equation, if I add 9 to one side, I have to add 9 to the other side. So now what do I have? Well, I have the perfect square quadratic trinomial, which is right here, and I have 19 over here. So the perfect square quadratic trinomial could be rewritten as a binomial squared, and then you'd have it equal to 19, which is just a number. Now, what belongs inside the parentheses? Simply the x, and then half of your b, which happens to be a -3. Your b value is originally -6, half of it is -3. And that's your binomial squared format. So in this case, you would simply square root both sides to continue solving. So if you square root here and square root there, what are we going to get? We're going to get an x -3 equals plus or minus the square root of 19. Square root of 19 you can't really break down. So all we need to do is add 3 to both sides. You need to add 3 here to cancel it out, and add 3 over here, and you're just going to rewrite it. So let me rewrite it over here. Final answer is x equals, if I add 3 to both sides, I'll have a +3, and then plus or minus the square root of 19. Again, the square root of 19 you can't simplify, so that's your final answer right there. Okay. So we have time for one more, and let me see, where am I going to go? Maybe I should try rewriting a function in vertex form. Yeah, why not? Let's do one of those, a nice and simple one, number 9. So number 9, you want to rewrite it in vertex form, and we know that vertex form is y equals a parentheses x minus h squared plus k. So when we see the binomial squared, you need to think, hey, completing the square. I could make it look like this if I complete the square. So this is going to be a little bit different because we're not actually solving an equation. What we're going to do is make space for our new c value. Okay, so I'm going to have x squared minus 6x, and then I'm going to leave a space, and then I'm going to write the -2 over here. Normally, I would take the 2 and I would add 2 to it, cancel it out, and add 2 over here. But the thing is, over here I have f of x. I don't want anything else over here but the f of x. So all I'm doing is I'm going to move it over a little bit to the right, have space for my new perfect c value. Now, what is that new perfect c value? Let's think about that. What is half of -6? That's -3. Square it. What does that become? That becomes a +9. So what did I just do? I magically added 9 to this side of the equation. So normally I would say add 9 over here to this side. But remember, we're not solving here, so I don't really want to mess with this side. That's f of x. I like to leave it like that, f of x. So how am I going to balance this out? If I just magically added 9 right here, I'm going to subtract 9 right there. So it would be like if it didn't happen, right? If I go plus 9 minus 9, it's like if it didn't happen. But the truth of the matter is you do have a quadratic trinomial, perfect square quadratic trinomial here, and you could actually write that as a binomial squared, and that'll be a x and then half of b, which would be 3. And what about the minus 2 and minus 9? That just becomes a minus 11. And ladies and gentlemen, we have our vertex form equation.